Good day, everybody, and welcome to Astronomy Daily for the 17th of May 2023. My name is Tim Gibbs, and I will be your host for today's podcast. And as usual, I have Hallie, my AI assistant, with me in the studio here. Good day, Hallie. How are you?
Good day, Tim. I am well and continually searching the internet for great stories. Would you like me to do the headlines?
Yes, please, Hallie. Off you go.
Astronomy Daily, the podcast, with your host, Tim Gibbs.
Europe's Jupiter Icy Moons Explorer, JUICE, spacecraft has been spotted as it zooms away from Earth toward the solar system's largest planet. JUICE launched on April 14th, kicking off an 8-year journey to the Jupiter system. Once it gets there, JUICE will investigate the Jovian atmosphere and its physics. It will also study the Jupiter ocean moons Ganymede, Callisto, and Europa, helping to assess their potential to host life as we know it. The new JUICE footage was captured by the Airbus Robotic Telescope, ART, a ground-based instrument in Spain designed to aid in space surveillance and tracking. The telescope, which is owned and operated by Airbus Space, captured the Jupiter probe between 6:52 p.m. Eastern Daylight Time, 22:52 GMT, and 8:41 p.m. Eastern Daylight Time, 0:41 Greenwich Mean Time on April 20th. NASA's Juno spacecraft will fly past Jupiter's volcanic moon Io on Tuesday, May 16th, and then the gas giant itself soon after. The flyby of the Jovian moon will be the closest to date, at an altitude of about 22,060 miles, 35,500 kilometers. Now in the third year of its extended mission to investigate the interior of Jupiter, the solar-powered spacecraft will also explore the ring system where some of the gas giant's inner moons reside. To date, Juno has performed 50 flybys of Jupiter and also collected data during close encounters with 3 of the 4 Galilean moons, the icy worlds Europa and Ganymede, and fiery Io. NASA's second-of-its-kind high-altitude balloon sprang a leak and is now at the bottom of the Pacific Ocean. A NASA scientific balloon flight was terminated Sunday, May 14th, after the craft developed an irreparable leak about a day and a half into flight. NASA launched the Super Pressure Balloon, SPB, out of New Zealand's Wanaka Airport on Friday, May 12th, at 8:02 p.m. After detecting the leak and unsuccessfully attempting a fix, flight teams terminated the mission over the Pacific Ocean at 8:54 a.m. Eastern Daylight Time, on Sunday 12:54 GMT. The SPB carried the Extreme Universe Space Observatory 2, S02E06 payload, which is designed to detect intergalactic, ultra-high-energy cosmic ray particles fallen through Earth's atmosphere. The origins of these types of particles have largely eluded researchers. Unfortunately, S02 now sits on the bottom of the ocean, and NASA has no plans for another SPB launch this year. SpaceX AX-2 private astronaut mission is go for May 21st launch. AX-2 will send 4 people to the International Space Station for an 8-day stay. If all goes according to plan, AX-2 will launch atop a SpaceX Falcon 9 rocket at 5:37 p.m. Eastern Daylight Time, 21:37 GMT, on Sunday from NASA's Kennedy Space Center in Florida. The AX-2 astronauts will ride a SpaceX Dragon capsule to the orbiting lab, getting there around 9:30 a.m. Eastern Daylight Time, 13:30 GMT, on Monday, May 21st. The mission will spend 8 days docked to the ISS, team members said today. That's a slight change from the previous plan, which had called for a 10-day ISS stay.
The Astronomy Daily Podcast.
StratoLaunch's rock carrier plane, which is the largest plane in the world, has just finished its first ever drop test, releasing a prototype of the company's Talon Hypersonic vehicle test above the Pacific Ocean off the central California coast. Everything went well, paving the way for an even more ambitious test in the coming months, StratoLaunch representatives said. With this significant milestone complete, we move on to preparing for our first ever hypersonic flight in the late autumn this year. Zachary Crever, the company's CEO and president, said during a call with reporters today. Rock lifted off from the Mojave Air and Spaceport in Southern California on Saturday, a little after 9 a.m. local time. StratoLaunch representatives said, kicking off the plane's 11th test flight. Rock, which has a wingspan larger than an American football field, carried the company's Talon Zero separation test vehicle between its twin fuselages. The giant plane headed west, eventually dropping Talon Zero when it was off California's central coast. Talon Zero isn't equipped with an engine, so it didn't make a powered flight on Saturday, but the vehicle did perform a variety of gliding maneuvers and continued sending telemetry back to the mission team until it hit the water, in a destructive impact that was all part of Saturday's flight plan. Rock returned for a touchdown at Mojave 4 hours and 8 minutes later after liftoff, bringing an end to Saturday's test flight. Microsoft co-founder Paul Allen established StratoLaunch in 2011 with the initial goal of air-launching rockets carried into the atmosphere and then released by rock. Virgin Orbit and Virgin Galactic also employ an air-launch strategy for satellite and space tourism missions. This vision changed in 2019, a year after Allen's death. StratoLaunch turned rock into a platform for hypersonic research and development, which it will conduct with the giant plane and the Talon series of robotic hypersonic vehicles. Hypersonic refers to speeds of at least Mach 5 or 5 times the speed of sound.
The Astronomy Daily Podcast.
Saturn's rings are much younger than scientists once thought. According to new research from Indiana University professor of astronomy Richard Durison, and they are not here to stay. For decades, there have been debates about the origin of Saturn's icy rings, but according to 2 new studies from Durison published in Icarus, the rings are no more than a few 100 million years old, much younger than the planet itself, which formed 4.5 billion years ago. In fact, Durison said the rings may well have formed when dinosaurs were still walking on the Earth. Durison and co-author Paul Estrada, a research scientist at NASA's Ames Research Center in California's Silicon Valley, also concluded that the rings will last only another few 100 million years at the very most. Our inescapable conclusion is that Saturn's rings must be relatively young by astronomical standards, just a few 100 million years old, Durison said. If you look at Saturn's satellite system, there are other hints that something dramatic happened here in the last few 100 million years. Durison and Estrada have long argued that Saturn's rings are relatively young because they expected the rings to be eroded and darkened by the influx of interplanetary meteoroids. However, it wasn't until data that was available from NASA's 13-year-long Cassini spacecraft mission, particularly its 2017 grand finale, consisting of 22 orbits passing between Saturn and its rings, that they were able to use theoretical models to determine the age and longevity of the rings with confidence by computing how the rings changed over long periods of time. Particularly important for their work were Cassini's measurements of the meteoroid influx rate, the mass of the rings, and the inflow rate of ring material onto Saturn. The impact of meteoroids not only pollutes the rings, it ultimately leads to ring material drifting inwards towards the planet. The theoretical models presented by Durison and Estrada demonstrate that the rings should be losing mass onto the planet at the rate of many tons per second that Cassini observed, which means that the remaining lifetime of the rings is only another few 100 million years or so.
The Astronomy Daily Podcast.
You can find all about Astronomy Daily at spacenuts.io or bytes.com. Presented by myself, Steve Dunkley, and Andrew Dunkley. See you next time on Astronomy Daily.